In this lecture, we talk about reconstruction of the binary tree from the given traversals. In the previous lecture, we have seen how to traverse the binary tree using pre-order, in-order, and post-order traversals. Now, given pre-order traversal and in-order traversal of a binary tree, can we reconstruct the tree is a question here. Suppose here in an example, two traversals are given, pre-order and in-order traversals. Now, if you look at the pre-order traversal, obviously node comes first. So the root node should come first in the pre-order traversal. It's an indication that A is a root node of the binary tree. Now, if you compare the vertices in the in-order traversal, HDB lies to the left of A and FCG lies to the right of A. So by combining this information, we can observe that A should be the root node and HDB forms the left subtree and FCG forms the right subtree. In the first stage, we can construct the binary tree. Now, when it comes to HDB, again, if you compare the vertices appearing in the pre-order traversal for HDB, B comes first. So B should be the root node for the subtree, left subtree, and D and H should become the nodes of B. Again, among D and H, D comes first. So B should be the child of B and H should be the left child of H. This is how we can reconstruct. Similarly, on the right hand side, FCG is the in-order traversal. It's an indication that C is the root node and F lies to the left of C and G lies to the right of C. It's an indication that C is the root node among the subtree and F is the left subchild and G is the right child. So A is the root node and B and C are the children of A and H is the left child of D and F comma G are the left and right children of C. Another combination is in-order traversal and post-order traversal. So given the in-order traversal and post-order traversal of a binary tree, can we reconstruct the tree is an issue. Now if you observe example here, in the post-order traversal, whatever be the rightmost vertex, that should be the root. So obviously A should be the root and HDB, FCG, FGC are the vertices that are appearing to the left of A. Now if we compare the in-order traversal among these vertices, HDB lies to the left of A, so it forms the left subtree and FCG forms the right subtree. Again, if you compare the subtree part of HDB, in the post-order traversal B comes first among these three vertices. So for the left subtree, B should be the root node. Similarly, for FCG in the in-order traversal, FCG, C should be the root node and F and G should be the children of that. Again, among H and D, if you compare, in the post-order traversal, D comes first. So D should be the child of B, H should be child of H, left child of H. Similarly, among C and G, G comes first. So G should be the right child and F should be the left child. This is how you can reconstruct the binary tree. The next question is, given pre-order and post-order traversals, can we reconstruct the tree? We cannot reconstruct the tree for all cases, only in specific cases we can reconstruct. Why? Because, for example, if you look at the scenario here, B is left child of A. Suppose if I take B as a left child of A, the pre-order traversal is AB and post-order traversal is BA. Now, if B is the right child of A also, the pre-order and post-order traversals are same as AB comma BA. So just by looking at the pre-order and post-order traversals, we cannot judge whether B is left child or right child of A. So this ambiguity remains, and in general we cannot reconstruct the binary tree. However, we can do this in special cases. Full binary tree is a binary tree in which at each level all vertices are present. For example, in this case, at 0th level one vertex is there, and at first level two vertices are there, and at the second level 2 power 2 4 vertices are there. So in general, in the full binary tree, at each level all possible vertices shall be present. At the nth level, 2 power n number of vertices shall be present. Now in this case we have pre-order and post-order traversals. If you observe the traversals, A is the leftmost part of the pre-order traversal and A is the rightmost part in the post-order traversal. It's an indication that A is the root node. Once root node is identified, the left and right parts shall be identified. This can be done in two ways. Here, one way is it being the full binary tree and there are 7 number of vertices and A is the root node. Obviously, the left subtree and right subtree should have equal number of vertices. So it should have, the left subtree should have 3 vertices and right subtree shall have 3 vertices. And if you observe the pre-order traversal here, BDE is one part because the same part is jumbled in the post-order traversal, and CFG is another part where FCG is jumbled in the second part. So 3 verses are to be taken as BCE, BDE, and another 3 verses shall be taken as CFG. The 6 verses are divided into equal parts. Now among BDE, B comes first, so B should be the root node for the left subtree of BDE. Similarly, CFG, C comes first in the pre-order traversal, C shall be the root node in the right subtree. So based on this, we can progressively reconstruct the tree. Among D, E, D comes first in the pre-order traversal, so D should be the root node in the left subtree of B, and similarly F shall be the left subtree of C. And G comes last, so G should be the right subtree of C. Similarly, E should be the right subtree of B.